The next topic that we are going to discuss is the different types of agents. Now, the different types of agents depend upon how much of decision can they do, how much of decision can they make, what kind of control is it having, does the system have a lot of control or is it having less control. So now depending upon that, this is we have different four types of AI agents. So now this will depend upon how much of autonomy are we giving the agent and how much of control do we want to retain on the human side. So if it is a very critical system, we want to retain the control on the human side. Now again, this is not like one kind of system will fit all. Rather it is contextual. It is based upon the problem. So the first one is rule-based agents or controls. Now here there is low autonomy. Low autonomy means the agent is not able to take control, or it's not able to take decision on its own, and it also has high control by the human. So these systems, they are rule based systems. These are more like software based systems, and they do not use any kind of LLMs. They are built with traditional if this then that logic, and here the decision path is manually scripted. There is no reasoning or learning. Here rule based agents have already been always in use. So here we should always remember that it is the problem which is coming first. If we can solve it without AI, we should not complicate it. So what kind of problem can such system solve? It can solve well structured, which are the repetitive tasks with fixed inputs and outputs. So examples will include it will automatically approve reimbursements which are under a fixed amount. It will rename the files in a folder based on the file name patterns. It will copy data from Excel sheets into form fields, and it is fast, auditable, predictable. It is it's not going to change. It cannot handle any ambiguity. And so when we know what are the conditions and there is no flexibility that is needed, and it's a clear cut system, then in that case we can make use of rule based systems. Now the next one that comes as workflow agents. Now here the workflow agents is, this includes moderate autonomy and high control. Now, high control as in it's the human which is finally deciding what has to be done, but there are LLMs which are enhancing that entire workflow, but it will not execute the action independently. Rather, the final decision whether the action has to be taken or not stays with the human. A human stays in control always. So here, what problems can such kind of workflow agents solve? These agents can solve some kind of repetitive task that benefit from natural language understanding, summarization or generalization, but they still need human decision making. So the LLM is internally working, but finally to do the decision, it is the human which is doing the decision. So the examples can be suggesting first draft responses in a support tool like Zendesk. So some kind of like for example uh, responding to a simple mail. So again it shows me in gray, but then once I click a tab on it, so it's showing me the response, but the decision remains upon me whether do I want to go ahead with that resp- response or not. And then generating summaries of meeting transcripts, this is again only the LLM job. Translating natural language queries into structured search inputs for BI dashboards. So this is again can be a simple workflow agent task. Here how the LLM is used, it will read the input, it will check the context, and it will always generate useful content, but it will not act upon it. Once the human clicks on some button, clicks on it, then it will act upon it. So it is easy to deploy, low risk, quick value, and it can't execute a plan. It is limited end to end value. It will be best used when we want to augment the team's productivity. Consider it like the next word prediction. That's again one good example of this workflow agent. So it wants to augment the team's productivity, but without without giving up oversight. That means without leaving any space, leaving any point for without leaving any point for any mistake to happen. That is, the final decision is with the humans. The next one is semi-autonomous agents. Now these semi-autonomous agents, they have good autonomy and they have moderate control. That means they can take some decision and some action without humans. So with some kinds of minimum supervision they can work. They are the true agentic systems. They can understand the task and also perform multi-step actions, invoke tools and complete the goals with minimal supervision. And they often operate with some constraints or monitoring built in. So now they can solve some multi-step workflows that are well understood, but it is too tedious or time consuming for humans. Examples can be a follow-up agent that drafts, personalizes and sends emails based on CRM data while logging results, a document automation agent that extract details from contracts and updates internal system. So here, consider depending upon some kind of report, I'm supposed to be sending mails to mails for based on certain CRM data, or extracting the details from the contract. A document automation agent helps me to fill in some internal system, or otherwise a research agent is helping me to take some data from multiple sources, check on the findings and also send a structured report. So these kinds of systems can help me in that. Now here the LLM will be used for planning the steps. It will call the necessary APIs to perform the task. It will keep track of the progress and it will also check if something has gone wrong. It will include fallback paths. Fallback paths will help me to check what has gone wrong and to redo or undo the action appropriately, and also checkpoints for human review. So the pros will be it will automate complex workflow, save time, higher return on investment. It now, because this needs steps, it will need a lot of infrastructure to execute such a task, and it will be harder to test. So we can you make use of this when we have well bounded business workflows and we want to retain certain control, but certain control can also be vested with the agent. And the last one is autonomous agents. These are complete autonomous agents. One very good example of these autonomous agents are the self-driving autonomous cars. So they are fully goal driven. They know what has to be done. We give them a broad objective and they figure out what to do, how to do, when to retry and when to escalate. Now they can act independently, often across systems and over time. So what problems can they solve? They can solve high effort, async or long running tasks that span multiple systems or steps and don't need constant human input. So driving a car here, as we see, the self-driving cars is one example of such kind of systems. A competitive research agent that pulls data over days, summarizes updates and generate weekly insight briefs. So here it is considered a research agent that is also getting the data, summarizing it and also generating some kind of weekly briefings. An ops automation agent that will detect issue in pipeline, diagnose the root cause and files ticket with suggested fixes. So here it is checking for the issues. It will also check the root cause and depending upon the root cause, it will also generate the tickets. Then the next one is testing agent. Here it will run product flows, log results and suggest new edge case scenarios. So here the LLM will be the planner, the decision maker, the tool user, memory tracker and communicator. A lot of function go on here, and here it will manage retries, evaluates if goals are met, and it will also decide when to stop or adapt. Pros that it is scalable, it can handle complex tasks. Cons are it is high risk if it is not monitored, and it is hard to evaluate or trace. It is infrastructure heavy. So this can be used if the task is high effort and it does not require human feedback at every step. So in that case, it can be used. So how do we decide what type of agent? So we should check if the task is repetitive and structured, if it involves language understanding or generation, is it a multi-step task that needs decision making? Can we trust an AI system to do this task, or should we include a human in the loop? So if the problem type includes structured rule based, then a rule based system can help, like for example automatically improving reimbursements under a certain amount, or trigger invoice processing based on fixed thresholds. The next one is human led process. Here the human is finally taking the decision, it needs speed. So here suggesting some kind of response or summarizing meeting transcripts can be for workflow agent. The next one is semi-autonomous agents. These are multi-step, repeatable, and the bounded tasks. So there is some control that is with the humans, but some decision can be taken by the agent also. So this can lead to enrichment and follow-up. Like for example, fetching the CRM information, drafting outreach, sending the email, and the log interaction. All these tasks will be done by the semi-autonomous agent. And the last one is the autonomous agent, where it is able to do a variety of tasks, also take decision on its own, and interact across systems. These are complex asynced cross-system tasks. Consider an intelligent agent. It will monitor public news, it will check the data, get the data from multiple AIs, cluster whatever it is doing, and then it will generate weekly market reports. So these approaches need not be mutually exclusive. A particular single system can make your use of the can use a mix of them. So some parts might require high control while others can benefit from high autonomy. So depending upon the problem, we can check how it has to be solved. And sometimes we might need not just one single agent, but a group of collaborating agents. The next thing to see here is what are these tools that we talk about.